those are patterns of behavior that we can actually document. Part of what we're going to look for, I want you to think about, a baseline is documentation not just of an instance, but a pattern. The other thing I want you to always be able to do, document a problem. So when you look at the baseline, have I documented a pattern? Is that pattern different than what we want? And that's going to be a social statement, not necessarily a scientific statement. This is a pattern of behavior that we don't want, that we want to change. All right, the design needs to control threats to internal validity. One of the biggest things that I really want you to really focus on, we in single case methods agree with all of the threats to internal validity that Campbell and Stanley or Shadish, Cook, Campbell, and Stanley all have identified. And if you haven't read those little handbooks, you need to go back. It's like, you know, if you're in China, you've got to read Chairman Mao. If you're really doing research design, you need to understand Campbell and Stanley. So threats to internal validity, the primary threats of history and instrumentation and whatnot, are the target of single case methods. So there is not a difference between group design and single case methods in adherence and concern for threats to internal validity. The difference is in how those threats are controlled. So keep that in mind as we go along. One of the biggest issues is going to be this issue around a standard that has emerged looking for any single case method that is actually designed as experimental must document what we're going to call a basic effect 3 times, each of those times at a different point in time. So when do you say that you have a design that meets design standards? When you have demonstrated a basic effect, a change from baseline to intervention, and you've replicated that a minimum of 3 times, and those replications are at different points in time. So we're going to come back to that. But part of what I really want to emphasize is, just as with group design, replication is at the heart of everything. And I love the fact that Joel Levin and Tom Pratowell are really advancing the use of randomization tests, because part of what they're taking advantage of is the likelihood that you would get the same effect under basically statistically random context. So part of what we're looking for, I want you to keep in mind as you look at, yeah, it's getting hot, but that's only because it's really exciting stuff. All right. So design controls for threats to internal validity primarily by looking at replication. And the ways that we do that are going to occur over and over again. Now the visual analysis pieces, those are the parts that we're going to spend time talking about. Essentially, here's the big thing I want you to write down. Right now, when people do visual analysis, they stipulate on level change. Level change is really sweet. It's something I want you to know and love. It's insufficient. There are 6 variables that I want you to use when you do visual analysis. Level, trend, variability, overlap, immediacy of effect, similarity of similar phases. So we will come through and we're going to do each one of those. One of the reasons why we struggle statistically to assess single case methods is we don't have an algorithm that actually uses all of the variables that we've learned are necessary to do a sufficient analysis of single case methods. The last piece that I love, all right, those of you who are group design researchers, right? When you run a group design, part of what you do is you take your 2 groups and you assess them. You do the intervention with the experimental group that's randomly selected, and then you test the 2 groups again. And in most cases, you never look at the data until you're done. And then you say, before we looked, the 2 groups were similar. After we did the intervention, the 2 groups were different. Life is good. You graduate. You get a publication. All right. Now, Here's essentially, in single case methods, I want you to change. So here's the rule. I want you to look at every data point within 24 hours of when the data point is collected. Every data point. I want you to look at the data point within 24 hours of when the data point is collected. I want you to be able to determine, as you are building the study, if things are working. And here's the reason. If you get a pattern of responding that's different than what you anticipated, I actually want you to learn from that. Given the logic model that you're using, come up with a hypothesis that says, why am I getting a different pattern than I would have anticipated? Modify the study so that you can actually test that. It's going to have implications for what you're able to say within the study, but in many cases, part of what you get with complicated single case methods is you get flexible adaptation to the data. And I'm going to give you examples of what that looks like and how it operates, but the basic idea is one of the things that you do in at least one approach to single case methods, the researcher is very actively engaged. Now, John Farron and Joel Levin, again, are arguing that if you are brave enough to incorporate randomization into your single case methods, you give up some of that. So, but there's a trade-off. You get some improved experimental rigor, but you give up areas of flexibility. One of the things that I have especially valued about doing single case methods is the ability to modify studies as we go forward. All right, so that's basically everything I know. Now what we're going to do is back up and say, how does that fit together? So we're going to be talking about 3 major design features, and then we're going to get into how they work and how you're going to modify and adapt them. So the first, reversal withdrawal designs. Part of what you're looking for, in most cases, you're going to be looking at 4 phases. You do baseline, intervention, and here's the big thing. The thing I really want you to appreciate is the 3rd phase of a reversal design. The first 2 phases, everybody knows baseline, feels comfortable with baseline. Feel good, right? That feels good. Treatment, that also feels great. That's just normal clinical intervention. Getting that effect is cute, but insufficient. If the effect is really due to the intervention, remove or take away the intervention. And if you get a return to baseline, that is a phenomenal demonstration that the change that you saw was not due to some random other event. It really was due to the manipulation of the independent variable. There are very few examples in the history of science that use this level of real test. The reversal design is the most powerful design that we've got within the single case methodology. You can't use it for all dependent variables. You can't, for example, if you're doing a reading intervention study, say I did an intervention, it increased acquisition of oral reading fluency performance rates. Now I'm going to take it away, you're not going to get a drop, right? So you've got issues there. This is the point where you then replicate the effect. So here's one demonstration in which manipulation of the independent variable produced a change in the pattern. A second demonstration where there was change in the pattern. A third demonstration where there was change in the pattern. 3 demonstrations of the effect, each at a different point in time. Multiple baseline designs. Now, from here on, this actually is worth the day all by itself. When you design your multiple baseline designs, I want you to build in a minimum of 4 series. So the traditional message would be the minimum is to demonstrate 1 change, 2 change, 3 changes, each at a different point in time. But a multiple baseline design is among the more fragile of the single case designs. there are a gazillion things that can go wrong. And if Emmett moves to New York in the middle of the study, you are up a creek. If you've got 4 series, you're still able to produce a demonstrated effect. Also, this is great. If you're working with kids with ASD or you're working with kids with EBD labels, you by definition are working with kids who have differences that show up. You're going to have one kid that is not going to follow the pattern that you've got. So if you've got 4 series, you can then study the outlier, but your basic study will still work. So one of the strong messages to take away, when you initially design your multiple baselines, build in 4 series. Alternating treatments design. The alternating treatment design is different in the sense that rather than saying, does the independent variable produce a change over baseline, it basically says there are a minimum of 2 conditions. To what extent are these 2 conditions different in the way that they influence a dependent variable? Is she more social with peers than with kids she doesn't know? Is he more likely to join a structured game than an unstructured game? So what are the variables that you would use to predict? So you can create condition A and condition B, and you can say over time, let's first look at condition A, then look at condition B, then A, then B, then A, then B, then A. And you can do that and say, is there a difference between the 2? The research question in an ATD, in an alternating treatment design, is slightly different. It's not, does the independent variable make a difference in the dependent variable? It's, is there a difference between 2 conditions? So part of what you're looking for is situations where that makes sense. The power of the alternating treatment design is replication. Because part of what you do is you go from one condition to the other and back and back and back and back. So it is the rapid alternation that develops huge power in terms of inference that you can make. Now, there are a couple of quick digressions that I want. And I want to do these quick digressions. We're going to do these the fast way, partly because Professor Minta has told us that you are very, very clever people and you're able to do this really fast, all right? But it's also, both David and I serve as grant reviewers. So we read grants that are submitted to the federal government. There are 2 big foundational variables that have really served as a consistent problem in grants that we've reviewed. So we want you, for your dissertation presentation, for the research studies you're going to do, for the grant you're going to write, we want you to avoid these. So here are the 2 things. Oops. Sure you could open that. Come on. Okay, so here are the 2 things I want you to do. One is the way in which you do research questions, and the second is the building of logic models. So first off, research questions. Ready? Basically, when people write research questions, they don't write research questions that are sufficiently precise to be able to guide a single case method. So I want you to be able to write research questions that deliver 4 features. Most research questions do 2, some do 3, very few do all 4. Always, within the research question, you're going to start with the dependent variable. So what is the variable of interest? Second is you're going to describe the independent variable, typically across multiple conditions or rates or levels of the independent variable. There are 2 things that I really want. State within the research question that you're interested in a functional relation. Is there a functional relation between manipulation of the independent variable and change in the dependent variable? But here's the 4th. I actually want you to write, what is it about the dependent variable that will change? Will the dependent variable change in level, in trend, in variability? What is it that you're interested in? If, for example, you're doing a study and you're actually looking at modifying heart rate, you may not be interested in modifying the absolute level of heart rate. You may be interested in looking at the variability. That's what